Hello all. I'm not going to share my screen because I just look really messy. And I'm eating, and drinking. But I just wanted to look over this Excel data because we did go over it before on the Lyme disease data where we had negative values and other gene expression values positive, but what we had for the Lyme disease in our pathologies database of 600 genes showed negative values were. That's how they. Now, we found online that it was z-normalized, which means it takes the standard deviation on the bell curve, on both sides. So what we want is we want to squeeze these numbers into the positive rules so there's not any negatives. Usually they do that in normalization, log normalization between 0 and 1. But I don't think we're really going to get, you know what, this is how we get values between 0 and 1. We found it before, and it said to take, let's just make sure we're doing it right, but it said to take the normalized method. Let's see. So is it the x minus x divided by the range of x, which is max minus the min across the genes. So it is actually, let's see, like this one says, okay, so it uses the code in there. Normalizing minimum 0 and the maximum component. Oh, okay. So min max scalar. All right. So what we want, so we want to take x minus x min, x max minus x min. So it's x minus the minimum. Okay, so it's not max minus x. Okay, so let's just make sure. Normalize values between 0 and 1. X minus the min of x divided by the range, which is the max minus the min. Okay, so it's actually x minus the minimum of x. That's what we're going to do. So we're just going to go to our Excel. We're going to actually work in here. Let's save this as an Excel workbook so that we can save multiple sheets and it won't just erase everything we did once we save it back to CSV, because that's what will happen in Excel if you don't save it as a workbook and you do multiple sheets, because it'll just save the sheet you're on as a CSV and it'll just erase everything else. Okay. These rows. These are all samples. Let's call this samples only. Okay, let's go with Leon, because we actually, for here, we don't know statistical values. Here, CI. '86 samples. So, and we'll just copy to the samples only. We'll paste it. Let's make sure it didn't give us some other rows. I don't like when it does that. Not particular details, because sometimes it seems like I do that and it gives me like infinite rows. like we did whenever we selected one and then we wanted to select all to the down without having to scroll through everything. Then it just scrolled and it pasted that same formula down. Way more rows, like 100,000 rows instead of 20,000. So there are shortcuts in Excel, but to be exact, we're going to erase all these fold change ones since we, okay, which one is it? This one. All of these other ones, we're going to delete them. So it deletes those. Okay, that's our last sample. So now what we're going to do is, because we left the gene here, we're going to make a max. This is going to be the max of the genes. This is going to be the min of the gene. We have to do separately because in order to copy this formula across columns, we have to make it fixed on CJ and just change the row number as we go across. Otherwise, it'll change the whole formula and you won't get it. So that's the only thing. You do the column or fixed row or fixed column and fixed formula. Since we know we have 80, Excel has these letters across the top, like so we got the max as a range from B2 to CI2, min the same, B2 to CI2. It's relative to this row. And we're going to take that formula. We're going to actually call this range of max, min. And then this formula, I'm going to fix the min minus the changing sample across the row divided by the formula. Okay, so we're going to call this the formula, normalize. And then we're going to divide it by the range. But we do need the min and the max because the range requires the max. So that's why. All right. So we're going to go ahead and put our first formula here. $. We're going to keep, yeah, it equals the max of, we're going to do the B2 to CI2. And this equals the min. We don't need right now. B2 to C2. We will in the formula though. And this equals max. Wait, this equals actually, this just equals CJ minus CK. Oops, I meant 2. Okay. CJ2 minus CK2. Always call the column the row. So now we're going to do the $signs. This equals the min, which is CK, but we're just going to put 2 because we're going to scroll across. We just want to keep the column the same, but we want it to change the number on the row with each row as we scroll down and across. And then it'll keep CK2 minus, we're starting with B2. Oh, yeah. So actually, this is going to be the first gene. Minus B2 divided by CL2. Okay. So it's CK, the min, minus the value in B2, divided by, so these numbers are supposed to be between 0 and 1. This is already a 0. The first value is a 0. Okay. And then CL2, which is our range. So we got the minimum, CQ2, minus the value in that sample divided by the range, which is the max minus the min of 2. We've set CK to be the same and CL to be the same. Now this is actually going to be, the beginning. Okay, and now we're going to go to the end. We're going to count 86 columns. It hovers. It's supposed to hover. It's not hovering though. Why isn't it hovering? Okay, I'm pretty sure that's 86. It ends with CL. Also, whenever we go across, we'll look and see. We're going to go ahead and drag this across to the. And let's look at this formula. It is CI. So this is the ending. And it still keeps the same column, same rows. Now we're going to drag it across, down. So we're actually, let's go ahead and highlight this and drag it down. Let's see if it's keeping it. CK minus, okay, and then CL, good. And then here's CK. All right, great. Yeah, so it's going row for row. It's changing the row as we go. Fixed. All right, good. So actually what we could do is we can just go from here and then we're just going to have to drag it all the way. All right, let's go. There's less than 20,000 genes, so it's not going too slow. Almost halfway there already. I believe it was at FT was the column, so we're going to drag it across to FT as well. We're almost at the end. All right, so we'll put it right here. Now let's drag it across to FT. I believe it's right here. So waiting for it to fill. Here we go. All right, let's check it out. Oh, that's not cool. And then this one ended up being a different. What's going on with that? So actually, back up. Right. This is still min. This is min. Okay, we're just gonna have to do this one at a time. Okay. So otherwise it's just gonna mess everything up. So we'll go ahead and do it for each gene. Let's just check. Okay, make sure it's doing it. Yeah, 210. Okay. I just gotta make sure the values are right. It's better than entering it manually, right? Okay. I mean, there are software programs too that already do this. I think a really great bear fell off this mouse pad. Seems like it goes faster sometimes. The pups love each other. They're all runts in the litter. 3 of them. They just adore each other. They're so cute. Sweet little babies. Okay, let's keep going. Fell off the mouse pad. Okay. Let's make sure. Seems good. My phone will shut off on me. I'm paying payment crappy phone too. And then it gets blocked by somebody else's Wi-Fi too. And I got it for the satellite capability just to log on to the Starlink. Freaking if there's a Wi-Fi right there, like my own Wi-Fi or someone else's, I can't access the freaking satellite. So stupid. All right. All right, now let's see. So this is the range, CJ, max minus min. That one is actually okay, but then this one, so it's CK min minus that value. And it should be the first value divided by, okay, and then this one, that one looks, but then something happened where right here it max. So I'm going to go ahead and just use this column. We're going to drag it down. Okay, let's see where it's at. Okay, and then, oh, you know what? Actually, let's just go to the top. We're just going to use this column. We're going to drag it, that little square, all the way down to the bottom. We're going to keep boxed in and then drag it across so that only this formula, because it's copying the others in the rows, the columns that I had selected originally, to go down and then across. So that's how we have some that aren't under the max or the min or the range. So we have to just copy this column formula and pull it across all the rows. Okay. Bring it down one. Okay. We're going to go across. There's still some negative values. There should not be any negative values. It should be between 0 and 1. The min, the value, divided by the range. Which seems weird because you would think it would be max minus the value. Unless the min was larger than the max negatively. Oh, on the other side. Well, because we want to get rid of these negative values. Alright, so let's go back up to the top. That really sucks. A lot of negative values. Minimum, max. So max minus the min. Seems fun. The app minus the min. I mean, or even if you just minus even the first few ones, it seems like they are larger. The max is larger. Let's just scroll down. So even right here, like, why is it showing negative values? There shouldn't even be enough. Oh. CK is the min. Max is CJ. So 1.13, 0.7, it still should be positive divided by the range. Because that's, so that's weird that minus a value and C on the same row. That should. What's going on? Hey, shut it. CK. There should be no negative values because the min is here, and we can check real quick. CJ minus CK. What the value is? CJ minus CK. Max minus min. Okay. Okay, so equals 2 minus CK2. All right. If equals formulas. If value cancel. Less than 0. If invalid. Oh, okay. If good. Value false. Not good. Okay. All right, let's set this formula. If 15 less than 0, good. And scroll all the way down. So we should have done max minus x if these are all going to be good. Let's see if we can do a sum equals sum of FB to FB 27. Okay. And we do identically equal to good. Oh, I guess not. No. Okay. So now we'll just go ahead and okay. Some. Maybe it'll do it if. Oh, this is 0. Maybe I didn't equal it. Nope. All right, well, we're going to have to change that. Oh my God. Okay. We're going to put 0. This is a 1. Not good. If it's less than 0. If it's greater than 0, which would be alternate, or equal to 0, and then it will be 0. Now we're just going to scroll all the way up. All right. Now let's go to the bottom. Let's do equals sum FB2 to FB19527. It's 0. All right. So what we need to do instead of the min minus a value is put the max minus a value in our formula. So our formula is right here. It's actually going to be CJ over CL2. And then let's work on down first. Let's test it first. Let's see. Yeah, that seems right. Good. Just the rows down the column. Down all the rows, across all the columns. Let me go down all the rows and then across all the columns. So we're going to go ahead and go across all the columns up to FT. Okay. Just make sure. Yeah. Let's see what it is. I don't know value, so that's really good. This seems like a better choice for us. CJ, the max, minus the line. It's going across. Let's just pick at random. Okay. Same fixed columns for divided by range. Okay, good. Now, normalized it back. So, go ahead and save this. Save it as an Excel workbook. We're going to make another sheet, though. We're going to copy all these values right here. And paste them here. We're still waiting for it to finish copying and pasting. Let's look. All right, so for this one, we don't need these two. We're going to delete them. Now, we can't delete these yet because we have to save it as a CSV first. Okay, so right here, we're going to Control-C copy. It's 86 columns, and we're going to Control-V paste to 80 for FT. All right. So normally you can't have the same column. Go ahead and rename. Oh, I should have put paste the numbers instead. Okay, that's fine. I should have pasted on my numbers. Well, you know what? It's not too late. Let's go ahead and copy this. Copy. I'm going to go over here, highlight it, and we're going to paste as a number instead of formulas. Formulas. Oh, why are some of these still negative? Yeah. Not be negative after all that work we did. So if you take the max of a range and you minus the min, if it's above 0, any number that is a value in that range will be above 0. We tested it right now to see if the max was, let's see what the formula says. It still says CK. It's supposed to say CJ. What the fuck, dude? I copied it across too. Freaking dumb. It's supposed to say CJ. Okay. You know what? It didn't copy this formula all the way across. What the hell? Oh, annoying. We have to do that all over again. Let's say I have a list. -25. The range is -25, the lowest minimum value in that range. And you have a positive. The max is like 99. 99 minus -25. Above 0. Because negative minus a negative is a positive, right? Why would any number between the minimum and that be larger to make it negative? It wouldn't happen. So this is obviously the formula error, and we just confirmed that it was. So we have to go all the way down to the bottom. 19,527 rows. Let's see. We'll look positive. We did copy it all the way from the top, right? Okay. I'm not seeing any negatives, are you? We could do another test also. Okay, so they should all be good. Let's see if we can do that. So it's from CM. Okay, let's test that. Oh, no. Ah. What's the problem? They don't like apostrophe? I don't know what this. Why isn't it working? What does this mean? Huh. CM2. Is it the wrong if? Maybe it's this one. If. Oh, shit. Oh, that's interesting. All right. Looks like a bunch of good. Delete that. Okay. So this is good. We're going to go ahead. Now we're going to go ahead and copy this into a folder. I'm going to this other sheet. Waiting for it to be done processing. Oh, we forgot to copy and paste it as numbers. Oops. Let's wait for this and then do it. Oh, so it's taking a long time. Very weird. Oh, we got a workbook. It's taking so long. All right. So actually, we get to copy this. Copy, and then we have to go over here and paste it. It's a number, so it's value, so that we don't have formula. Okay, that's good. They're all great. We're gonna go ahead and call this normalized 0. I don't know if I want to do that. Okay, it does. We're gonna erase these two. We're gonna copy these sample IDs. And there's 86 of them. And we're just gonna paste them along the top here. Control V. Now we're just gonna delete all this other stuff, except for the gene column. Okay. Seems like everything pretty much. Or let's save it as an Excel workbook first. It's a workbook. Good. Save it. Yeah. Now we're going to save the sheet as a CSV. So, file save as CSV. It's going to be, we're going to name it something else. All right, let's open it. It's been almost an hour, so we're gonna. Lyme disease one. Oh, actually, we need to go to the all pathologies one first, and then the Lyme disease one. Let's open it up. Okay. So if you highlight all the columns, and then you go right here, you double click, it will automatically expand them out. So it looks like they're all ordered. The health. And the acute. And the antibodies 1 month. And then the antibodies 6 months. Okay, and that's the samples. So what we're going to do is let's shrink this down. We're going to make a notepad to keep track of it because we're just going to do this in Excel. All right, we'll just do we'll erase this one. And then we'll keep track of Okay, so the healthy, by columns, the acute, the 1 month, and the 6 month. Okay. All right, so CL for 6 months. CL 6 months. BZ to CL. Okay, BZ to CL. BZ to CL 19/27, right? Okay. And the 1 month is 1. 27, but it's that. We'll just save it as it is. Okay. Let's just go into our studio real quick. Everything was saved. I don't know why it's saying that. Okay. Let's go find this folder. We're just going to change it within here. So the script will only be in this part. I'm going to create a markdown for it. We're going to save it as and we're saving it in a different one. Why would it save? Oh, because we didn't set the working. We did though, didn't we? Okay. No, I guess we just went to it. Okay. Save it here. All right, let's set this as our working directory. Okay. Oh, it's a script. No, I wanted an R markdown. What the heck? R markdown. Lyme disease normalized data modified 0 to 1. Let's make a bunch of chunks. We modified these data from having negative value with the normalization of the bell curve, Gaussian curve, two-sided values between 0 and 1 with max minus x divided by range. Okay. max minus min. And we wanted to okay. Let's do columns. Let's do some of it later too. Zero to one, or some are one, some are higher, but they're all positive, so that's good. Okay, let's go ahead and let's just grab it. Acute grab. Acute. Healthy. Month one. Month six. Okay, looks good. Shows how many samples are each. We're going to need that because we're going to add in our means. Healthy mean equals means of data healthy. Okay. Cool. Same. Data by acute. Oops. Okay, let's run these first. All right, so that's acute infection. That's 1 month of antibodies after acute infection. That's 6 months. Acute meaning when they went to the clinic, whenever that was. These are the first 2 weeks. If you're not feeling good, if they go at all. Okay, data by right. 6 months acute. Let's order it by 6 months healthy. And then by 4 to 6 months healthy. Decreasing equals true. Let's get a summary of the order for the last columns. 80 to 95. All right, there's no NAs. That's good. Let's write out data order because we're in that folder. So let's go ahead and write this out. This is only staying in this folder, so we don't need to do anything else to it. We don't need to make evaluation. We can knit it though, just to see what it looks like when we read it out. It won't. We don't want to knit it. We're not going to publish it though. Yeah. Here. Changing my beer. All right. So this shows us what we have. Great. I'm not going to publish it, but I will add this database. This Lyme data set can be found here. We can erase all the other chunks. I'm going to put it on Google. Let's look at Google. This is it. Oh, it's a large file. Surprising. Oh, it seems to be really slow. I did import it, didn't I? Come on. The heck? What the heck? I just freaking imported it. Ugh, it's probably just taking forever. Which is not very cool. It's empty. So fucking dumb. I can't believe it's that freaking large of a file either. Oh. It might not let me because it's kind of large. It just seems like it's the regular size of the other ones, but maybe because I used Excel. Extra information. Oh yeah, it did, because their values are like 16,000. decimal places. Okay, 16 decimal places. Let's see. There are a lot. I've seen some of them are really large. Okay. Right. So go ahead and share this. Copy the link. Oh yeah. I guess I will go ahead and share this with you. But actually, you know what? I didn't publish it, so I was kind of pointless to put it there. Huh? I just, you want to really put your best publications there. Yeah, okay. So that's been an hour and a half. We have that folder. Oh, let's go play around with Tableau. All right. So this will be in the non-EBV associated genes. We want this someone. We will have to. We can just leave the Lyme disease fold change values as they are for top genes in that pathology database. We were originally going to, maybe we still will, use that pathology database to build a machine model that can predict the class. I mean, we could just do that now. I mean, it's going to be a very large classifier, and the random forest classifier really does not do so well after 2 classes. It degrades dramatically, and the accuracy is very, very poor overall. But maybe it can tell us some connections. But we can't possibly use all the genes in that model. We have to use the top genes, and we won't be able to use all those genes, but we could select 2 different categories and compare across those categories on a model, machine model, so that it can see how close this classifier thinks any of these diseases, like these Epstein-Barr virus non-associated pathologies, are to each other. We could just select only the fibromyalgia and chronic fatigue, those top genes, and then put those in our model, see if it is good at predicting which one's fibromyalgia, which one's chronic fatigue. If there's good selection, then it means these are pretty distinct. If not, it could mean there's some overlap, and possibly there's some connections between them that make them very similar to maybe having a point of origin that's very similar too. All right. I'm a pessimist by heart, so I might read something and then be like, my peers discovered something else today. Let's see if it's true. Okay. All right, so here we are. Lyme disease right here. We're going to replace this one. Let's just go ahead and remove it from our dashboard. We're going to add a different Lyme disease. So we're going to go to our data source. I just clicked it, so I'll click it again. There we go. And I'm going to add all pathologies, the Lyme disease, this one. Okay. We're going to add this right now. We know it uses the gene symbol, so we'll be changing that. Gene name and ensemble. With gene in the Lyme disease data set. We don't have to add all the samples, so this one shouldn't take too long. All right. Got the P too. It's really use the restroom, huh? I think we use the restroom right now. Yes. Dallas is here. I'm going to create another sheet. Lyme normalized. Do I put the sample number in here? I do want to keep those this information right here. I'm going to copy that. And then we'll go ahead and add the gene. Then we'll add the field change values. We'll do the field change 6-month healthy first. And then acute healthy. And 1 month healthy. And then 6 months acute. And then we'll just go ahead and put the healthy mean first. And then the acute mean. And the monthly mean. And the month 6 mean. Let's widen these columns. Oh, great, let's go to our dash. Let's put this in front of the dashboard. Let's go to our dashboard. And let's add it. Let's move it to the empty space. Let's see if any of the genes are in it. Let's see. Lyme disease. Yeah, it only tested for up to 6 months, not chronic. Okay, so it's connected. That's good. And we can see 6 months healthy. Acute versus acute. The field change acute versus healthy. 6 months versus healthy. Slight changes. Almost to normal on this gene after a month. Initially, okay. Interesting. Deselect that. And then we'll put this on all. Let's save it. Hmm. Let's export it. Lyme disease. Lyme. Now let's save it to tablet public. It didn't take too long. An hour and 45 minutes. Okay. All right. Let's see if it works. Let's just pick a random. Well, not pick by pathology. All right. Interesting. Before we go, let's go ahead. I'm going to share this link. But also, let's look at that pathologist database. That's the latest one. Let's go ahead and go to filter data, filter. Let's only select the Lyme disease. 6 months because it only goes up to 6 months. That's why I put 6 months. Let me see the fold change pathologies. Really good. High ones and the negative ones. Okay, so there's 129. Wait, actually, there's not 129. Those are the row numbers. Okay, so there's like 33. It says 33 right here. Okay. Right here. Bottom left corner. Okay, there's 33 genes. We should put those values for that in our pathology database. But we don't need to do it the same way we do it all the time, by getting the top and bottom and the filtering for the same. We can just go in next time. We'll keep all of this the same, but we're just going to get the gene names. And then we're going to get the fold change values, the current fold change values. So the study summarized these fold change values. Lyme disease samples. Okay, so it doesn't tell you which fold change value this is, but it says Lyme disease 6 months, so it must be the 6 months versus healthy fold change value. We can also go into the report, but we'll do that next time when we do change our pathology database. We do also have to update all the tableau. We have 3 of them: the lymphomas, the gastrointestinal tract, and the non-Epstein-Barr virus associated pathologies. Currently, it looks like we're done. Otherwise, we're making modifications like we did this on the Lyme disease. And then we're going to see how a model predicts each class. We could do a class-by-class comparison for all the different types we have. Because if we go in here, you can see all the different projects we've worked on. I do want to do something with this Hodgkin's and the elderly with the diffuse large B-cell lymphoma. I think I'm just going to go back in there and just compare the diffuse large B-cell to using Hodgkin's as a baseline. Even though they're different, so I'll just do that, or I can compare, because I don't know if I have healthy samples. Let's filter that and just look real quick. So let's go in here, and then it's PBMC RNA peripheral blood mononuclear cells. So it wasn't anything fancy. They didn't take it from the tumors in the lymphomas like they did in the other Hodgkin's with the younger group. So this is just peripheral blood mononuclear cells. I might be able to get some healthy samples as controls from other PBMC. Let's see. Let's just get rid of that filter. Let's go to the media type. Put a filter here. Okay. B cells of PBMCs. Fibroblasts, LCOs, lymphoblastic cells. Tumor cells, PBMC. I want that one. PBMC RNA. What is this one? These next ones. Let's just look at all of them that are PBMCs. Oh, yeah, we also have to make sure that it's the same type of gene expression study, because microarrays are different from high throughput in comparing. But we'll just go ahead because it's a media type. All right, and so what we end up having are the multiple sclerosis. We only have 41 genes in that one because we had to manually find them. Natural killer T cell. Let's see the summary here. If it says how many samples are in each. Oh, use Sirot. Okay, and that's only for single cell RNA. It's a different format. But it has 3 different folders you have to extract from using this Sirot library. It's part of bioconductor for that type. That's a specific type of RNA. The nasopharyngeal. Let's see if they have healthy. No, this one I think it was still nasopharyngeal, but they just messed around with mutating one of the genes. They're all nasopharyngeal though. Okay, so this is the one we want to find healthy samples for. Okay, we have acute infectious mono. Let's see, are there any healthy samples? There's 6 healthy in this one. So we might be able to use this one just as a comparison. We'll have to merge 2 data sets together so we can redo the CHL Hodgkin's in the elderly with a large diffuse. So we'll do that next time, okay? Okay, great. Let me just make a note of that. We still compare the healthy controls. There, more. Cheese in sure. All right, that's it. So that's what we're going to be doing next. All right, you guys have a great night. Thank you.